Hello everyone, we are going to solve problem 19 of chapter 33. Determine the unstretched length of dB. Unstretched length means the original length of the spring, so that's our L naught of dB to hold the 40 kilogram crate in the position shown. Take K equals to 180 Newton per meter. So the question is asking for the unstretched length of our spring. According to the geometry, we have the final dimensions, the final length. We have 3 meter here, here is 2 meter. I can find the final length here. And I have the spring stiffness. So if I find the force, then I can find the displacement of our spring. So the first task is to find a force that is acting on member BD, or our spring BD. And to find the force, I need to use equilibrium equations. And before using equilibrium equation, the first step is to draw a free body diagram. So if I draw a free body diagram of ring D, I have the weight of the crate, which is 40 times 9.81, it's in kilogram, so times 9.81. I have the tension here, TdB, and also tension here, TdC. I don't have the angle, but I have the dimension. This one is 3, 2, so this dimension would be a square root of 13. So if I wanna, according to Pythagorean theorem. So for this one, I can draw a triangle here. This would be 3, 2, square root of 13. And here I have 2, 2, so that's an isosceles triangle, which means that these two angles are 45 degrees. And this dimension is 2 times the square root of 2. But I could write it in form of triangle as well. 2, 2, and 2 square root of 2 here. So in this free body diagram, I have 3 forces. I have written all the angles. The problem has not given me any coordinates, so I need to draw my own coordinate. Without a coordinate, then it would be meaningless when we write summation of forces in x or y. This means that the positive x is to the right and the positive y is going upward. Looking at the free body diagram, I have 2 unknowns, TdB and TdC. It's a 2D problem, so I can have 2 equilibrium equations, summation of forces in x and y. Therefore, I could solve for the 2 unknown. So let's write summation of forces here in x direction. These 2 forces are going to have a component in x direction. This force TdB is going to have a positive component, TdC is going to have a negative component. The component of TdB would be TdB times 3 over square root of 13 if I'm interested in the horizontal component. So that would be TdB 3 over square root of 13 minus TdC horizontal component 2 over 2 square root of 2. Or I could just simplify it, right? The square root of 2 over 2 equals 0. That's my first equation. Second equation, summation of forces in y direction equals 0. And in y direction, I have 3 components. Here in x direction, I had 2 components. This force did not have any component in x, but in y, all my forces are going to have a component as well. TdB, this time 2 over square root of 13 plus TdC square root of 2 over 2 minus, so in y, these 2 forces are going to have a positive component, and then my weight is going to have a negative component. I just multiply the 2, 40 times 9.81, that would be 392. So I write it here, negative 392 equals 0. So I have two equations and two unknowns. You should be able to solve two equations and two unknowns. The way we solve it, we find one of the unknown based on the other one. Let's say I move everything to the other side, move this component to the other side. I find TDC and I replace it here. After solving two equations and two unknown, TDB 283 kilonewton and TDC 333 kilonewton. So I found the tension in the two ropes or two members, but that's not what the problem is asking for. The problem is asking for the unstretched length. I did all of these to find TDB, the force that is acting on our spring. Got TDB according to the spring rule. TDB is K delta X. What is delta X? Is the deformation, is the displacement of our spring. So delta X would be TDB over K. What is the value of TDB that we found? It's 283. And what is the spring constant that we have? Is 180. So delta X would be 1.57 meter. Now that we found delta X, we found the deformation. We have the final length, we have the deformation, we can find the initial length. So we know final length minus the initial length would be the deformation. Now we have delta X, we have the final length, we can find the initial length, L naught. So that would be L minus delta X. What is L? Square root of 13. And what is delta X? Is 1.57. Therefore, L naught would be 2.03 meter. And that's what the question is asking for. We found the original length based on having the spring equation.